So in this video, we are going to discuss the question 12 of the counting tutorial. Now, the question begins with there are 10 men and 10 women. And the A part asks how many ways are there to arrange these people in a row. So we are dealing with 10 men, and at the same time there are also 10 women, and we want to arrange them in a row. So the row would essentially consist of 20 people all the way from the left to the right. Alright, so this is going to be position 20, this is position 1. Now, we don't have any restriction here as to how the men and the women are going to stand with respect to one another. So therefore, essentially we are just dealing with 20 people. And these 20 people comprise the 10 men and the 10 women. Then how many ways are there to put 20 people on a line? The answer is 20 factorial. Now, how do we get 20 factorial? Because the first position, which is the first position, there are 20 possible people to occupy that position. It could be any of the 10 men or any of the 10 women. The second position is 19, and then 18, and then 17, and so on, all the way to 3, 2, 1. And because we're going to fill up all the positions, it's going to be multiplication. And so, in total, we are going to have 20 factorial. This is for part A. Now, for part B, we are going to put these people onto two tables. Basically, they need to sit around two tables. One of the tables is blue, and the other table is red. So the blue table, there is a red table. Now, we have 20 people, but 5 men has to go to the blue, and the other 5 men have to go to the red. And similarly, among the 5 women, among the 10 women, 5 will have to go to the blue, and 5 will go to the red. Now, which 5 of the men will go to the blue table, and which 5 of the men will go to the red table? Now, is supposing that to choose among the men who are going to go to the blue table, there are 10 men, right? So we choose 5 of them to go to the blue table. Now then, for the remaining 5 men, they have no choice but to go to the red table. So similarly, among the women, again, there are 10 women. So then, out of 10 women, 5 will go to the blue. We need to choose 5 of them. So it follows that it will leave a remainder of 5 women that will then go on to the red table. So by now then, each table will already have 5 men and 5 women. So then how many ways are there for us to put the 5 men and 5 women around this table? Now, again, there is another condition that says that they have to be alternating. That means if you put a man, then the next one has to be a woman, and then a man, and then a woman, and so on. So then to simplify this problem, what we're going to do is to take the men first, and let's put them around the blue table. So for the 5 men to fix themselves around the blue table, let's fix one of the men, the man 1, to be the reference point. Now, once the man 1 sits, then we know that there are going to be 9 other positions, right? That the man can sit. The man and the woman can sit. So let's say, so another 1, 3, 4, 5, 6, 7, 8, 9, 10. Now, but the other 9 have to be ordered in a certain way. Firstly, we know that they have to be alternating, so we know that this one also has to be a man, has to be a man, has to be a man, has to be a man. So there are 4 men left, and they have to occupy this position. So in that case, then, for the men, there are going to be 4 factorial ways of putting them into the 4 seats with the man 1 as a reference point. Now that leaves the other 5 positions for the women. So in that case, then the 5 women would take 5 factorial to actually sit around the table. Now this is to take into account the alternating permutation. But we don't actually care about the mirror images because we consider them the same if they have the same 2 neighbors, whether they are on the left or on the right. So which means that if I have a particular permutation in a clockwise manner, if I repeat that permutation in an anti-clockwise manner, essentially we still get the same arrangement. So we need to divide that by 2. Now this is only what is happening on the blue table. So then on the red table, again we will have a similar problem. So then if we pick the men, and let's say men 6 to men 10 are the one that are assigned to the red table. So if we sit the men 6 first, so then this man will become the reference point to the red table. Now once we have the man 6 here, so then it will create 4 other position for the other men, which is the alternating position. So 1, 2, 3, 4. So 4 men, 4 positions, so 4 factorial. The other 5 seats then have to be occupied by women, so that's 5 factorial. And again, we remove the mirror images because we don't care about the right and the left neighbors, so divide by 2. So then this is for the blue table, this is for the red table, and we just need to multiply them and we get the answer to question 12b.